In today's video, I'm going to teach you how to perform chi-square test of independence in Excel. We'll walk through a clear, practical workflow you can reuse whenever you want to check whether two categorical variables are related. The chi-square test of independence looks at counts, not percentages, and tells you whether the pattern you observe is likely due to chance or reflects a real association. Start by opening Excel and setting up a simple contingency table with your observed counts. Put one variable's categories across the columns and the other variable's categories down the rows. For example, imagine responses of yes and no by male and female. Your table of observed counts might look like this. Yes has 30 male and 20 female. No has 10 male and 40 female. Add row totals and the column totals so you can see 50. Yes 50, no 40 male, 60 female, and a grand total of 100. Keep in mind, only the inner block of observed counts will be used in the test. Totals are just for calculating expected values. Next, compute the expected values for each cell. The formula is straightforward. Expected equals row, total times column total, divided by the grand total. Using the example, the expected count for yes male is 50 times 40, divided by 100, which equals 20. Enter that formula in the matching cell of a new table for expected counts, and fill it across all cells. A quick tip: if you reference the row, column, and grand totals in your formula, lock those cells as needed so you can copy the formula without breaking it. Also, make sure your expected table has the same shape and order as the observed table. With observed and expected ranges ready, use Excel's built-in function to get the p-value. In any empty cell, type CHSQ. Test, observed range, expected range, and press Enter. The function returns the p-value directly. The two ranges must be the same size and must not include your totals. Interpretation is simple. If the p-value is less than 0.5, the result is statistically significant, suggesting the variables are related. If it's 0.05 or higher, you don't have enough evidence to claim a relationship, and they're considered independent. Remember, this test uses degrees of freedom equal to the number of rows minus 1 times the number of columns minus 1. If you prefer to compute the chi-square statistic manually, create a third table with observed expected expected for each cell, then sum those values with each Compare that sum to a chi-square critical value for your degrees of freedom at your chosen significance level. Finally, a few quick best practices. Use raw counts. Ensure each observation is counted once. And be cautious if many expected counts are below 5. If the video has been helpful and want more tips, please subscribe to the channel. It's free.